Hello you guys, this is problem 8 of chapter 4, and here we have a 6 amp current going into a node where there's a 40 ohm resistor connected to an 8 ohm here. This is an 80 ohm resistor, and this over here is 120 ohm resistor, and this branch current is 1 amp. Okay, so we want to find V1 and V2, so the voltage drop across the 40 ohm resistor and the voltage drop across the 120 ohm resistor. The easiest way to solve this is to recognize that these two are connected in parallel. Therefore, they have the same voltage drop, and we can substitute that with its R equivalent. So it's the equivalent resistance. And that's what I'm going to do. I'm going to find the equivalent resistance and make a substitution to simplify my problem. So 1 divided by 80 plus 1 divided by 120 raised to first power is equal to 48 ohm. 48. So this whole thing can be replaced with a 48. Okay. So now we have, pretty straightforward, we have V1 here and V2 here. Okay, and we're going to take the ground as our reference node. So KCL at V1, KCL at V1, that is going to be, I have 6 amps going into, the 6 amp branch current going into that node, so it's going to be minus 6 plus V1 over 40 plus V1 minus V2, that's this branch current, over 8. And that has to equal 0. KCL at V2. Over here, we have V2 minus V1. That's all over 8 plus V2 over 48. We have a branch current leaving the node, so that's going to be plus 1. All that has to equal to 0. Over here, we're going to make our matrix of the simultaneous equations. V2 equal over here. I'm going to move the 6 over to this side. We have 6. Coefficient of V1 is 140. Coefficient of V1 is 1/8, so plus 1/8. Coefficient of V2 is minus 1/8. Down here in the second equation, we have 1/8 for V2 minus 1/8 over here plus for 148. And we're going to bring this over to this side. Gives us negative 1. Now, if I'm taking a test, I feel pretty good because I have symmetry. 1 negative 1/8 here and negative 1/8. You always look for symmetry in the diagonals because KCL is a symmetric law. Okay, so you have. If you don't, then you need to go back and find out where you made your plus or minus error. Okay, so now it's a simple task of putting it in our simultaneous equation solver. We have 2 equations and 2 unknowns. And then we go 1 divided by 40 plus 1 divided by 8, enter. Negative 1 divided by 8, enter. 6, enter. Negative 1 divided by 8, enter. 1 divided by 8 plus 1 divided by 48, enter. Negative 1, enter. And you should come up with V1 is equal to 120 volts and V2 is equal to 96 volts. That's your answers. Okay, good luck.